Notes on atoms, molecules, protons, neutrons, and electrons. First, you're going to watch the simulation and interact with it. Notice that you can click on these items here to identify what things are what. There's some information over here. You can do that also on these. And you can also take out items by turning off either atoms or molecules or mixture. Subatomic particles. Atoms are made up of three fundamental particles: protons, neutrons, and electrons. Please fill out the chart for the following next few slides. Pause as needed. At this time, please pause, log on to Schoology, and find the Edpuzzle via Schoology, Just How Small is an Atom, and watch that video. See you soon! Welcome back. I would like you to identify which dot is which. These are the blue ones, these are the red ones, and these are the black ones. Let's talk about something called the atomic number. The atomic number is the number of protons in the nucleus. So if you know the atomic number, you also know the number of protons. The atom of each element contains a unique positive charge in its nucleus. An atom's identity comes from the number of protons in its nucleus. So we know who the atom is based on the number of protons it has. Or we could likewise say we know who the atom is based on its atomic number. It is a whole number and the elemental block on the periodic table. Atoms are electrically neutral. They do not have a charge. In atoms, no charge, protons equal the electrons. So if the atom is neutral, if it's an atom, then its protons will equal its electrons. Here's a word spelled out using elemental blocks from the periodic table. This is your atomic number right here. The whole number is your atomic number. This number is called the average atomic mass. I said average atomic mass, not mass number. This is your average atomic mass. We'll talk about mass number, which is not these numbers, but close to them. We'll talk about mass number later on in this presentation. On your paper, write out a fun, school-appropriate word using the periodic table. How many total protons are in your word? Use this as your example. Atoms are neutral or no charge, as we said a moment ago. So atomic number, if it's an atom, the atomic number will equal the protons will equal the electrons. Think of APE. APE, atomic A, protons P, electrons E. A way to trick your brain into remembering. An atom becomes an ion when it gains or loses electrons. We call that a charged particle or charged particles. It's created when an atom loses or gains electrons. Atoms cannot gain or lose protons. Atoms are going to either gain or lose electrons. When an atom gains an electron, it has a negative charge. It means it has more negatives than positives. So it's a negative charge. This is called an anion. Think of the word onion. They are negative to smell. When an atom loses an electron, it has a positive charge. It has more protons than it does electrons. This is called a cation. I also have drawn a cat with plus eyes before to help you remember. Here's an example of an atom of sodium losing an electron and turning to an ion of sodium. So the symbol would be Na with no charge here. When the atom loses an electron, it becomes more positive and it gains a +1, or in this case, a 1+ charge. Similar, we have a fluorine atom, equal number of protons and electrons. It gains an electron, so now it has 19 protons but 10 electrons, so therefore it has a 1- charge. It has more negatives than positives. Please fill in your symbols in the appropriate spaces on your paper. Do not worry about the superscript if you can't figure out how to do it on your Chromebook. Just get it as a +1 and a -1. All right, let's practice. So we have magnesium. We're going to look up get a periodic table out and look up the symbol. Symbol for magnesium. Let me get my pen activated here. Is Mg. Protons are going to be 12. If you're looking at a periodic table. And if it has 12 protons and 10 electrons, then it lost 2. So its overall charge is a 2+. And its new symbol would be Mg, 2+. Here we have O, which is oxygen. And we know that its protons are 6. Let's try that again, 8. And we know that it's had 8 protons, and now it has 10 protons, so it gained 2. So its overall charge is a 2-. Its new symbol would be O, 2-. Aluminum is Al. It has 13 protons and 10 electrons, so it has lost 3. So it's going to have a 3+ charge. So it's going to be Al, 3+. Okay, so this is aluminum. Again, it has 13 protons. This one has 13 electrons, so it's not lost or gained anything. So its overall charge is 0, and it's just going to be Al for the symbol. Symbol has not changed. Nitrogen symbol is N. Nitrogen has 7 protons and 10 electrons in this case, so it has gained 3 electrons. So it's going to be a 3-, and its symbol will be N, 3-. Feel free to rewind and pause as needed. Mass number. Mass number is different than average atomic mass. The mass number cannot be found on the periodic table. Mass number, the number of protons and neutrons in the nucleus. Measured in grams, or AMU, or average mass units, cannot be found on the periodic table. Isotopes of an element have the same number of protons but different number of neutrons. Isotopes have the same atomic number but different mass number. We're going to spend some time specifically talking about isotopes in a few days. All right, I'd like to just talk about these are 3 isotopes of carbon. Notice there are 6 protons and 6 neutrons. So protons plus neutrons, that's 12. So the symbol dash a number, this number after the dash, when you write it out like this, always represents the mass number. We put the mass number on the top of the symbol to the left or before the symbol and up, like a superscript. So we have carbon 12, carbon 13, carbon 14. Look at how they differ. They all have 6 protons. They'd have to have 6 protons in order for them to be carbon still. But this one has 6 neutrons, totaling 12. So 6 neutrons, a mass number of 12, because 6 plus 6 is 12. Protons plus neutrons equals mass number. There's 13 for a mass number here, because 6 protons plus 7 gets me 13. Protons plus neutrons equal mass number. And then protons plus neutrons equal 14 for a mass number here. What are these 3 an isotope of? Please fill it in on your sheet. So this is an image to help you remember that ape. Remember ape was atomic protons and electrons. Remember that atomic number is the same as protons. Also, the mass number, mass minus atomic number equals neutrons. Mass number minus the atomic number gives you the neutrons. So just this is just a redo or relook at mass number equals protons plus neutrons. If I have a number of protons, then I take mass number minus neutrons. To get the number of protons, I take the mass number minus number of neutrons. To get the number of neutrons, I take the mass number minus number of protons. So that's just manipulating this generic formula or this given formula to solve for different pieces. Thinking about a nuclear symbol or atomic notation, a method of displaying information about a specific atom, ion, or isotope, it's also referred to as the nuclear symbol. So you would put the symbol here, and then to the left of the symbol as a superscript, you put the mass number. To the left of the symbol as a subscript, you put the atomic number or number of protons. Remember, these two things are the same. N in this image, N represents neutrons. So to get the mass number, which they call A, I don't know why, but that's what the textbooks all do. It'd be nice if A was atomic, but A in this case represents mass number. It is going to be your Z plus your N. So that's your protons plus your neutrons, or your atomic number plus your neutrons. You put the symbol here, and then you'd put the charge over here, as you can see right here, if you were going to add, if it had gained or lost electrons to become charged. So here we have a hydrogen atom. Why is it an atom? There's no charge here, which I have protons plus neutrons. So we know we have one proton, so we must have two neutrons to get to 3. Remember, the atomic number is the same thing as the protons. In order for it to be hydrogen, it has to have a 1 for an atomic number, because hydrogen has an atomic number of 1, meaning it has 1 proton. So I put the proton in place, and I add the neutrons. That's how I get my mass number. This is an ion of magnesium. How would I know it's an ion? Because it has a charge. This has 12 protons, or the atomic number is 12. In order to get to 24, I must have 12 neutrons also, because I know that it's going to be protons, 12 for this case, plus neutrons must be 12 to get to 24. Plus 2 charge means that I lost 2 electrons and became positively charged. Miss America? Miss America is a way to trick your brain into remembering that mass number goes on top, atomic number goes on the bottom of the symbol. So here's a picture of Miss America. So mass number, atomic number, mass number, atomic number, mass number, atomic number, mass number, atomic number. Okay, now we're going to put all these skills together that we've learned and fill out this grid. So you have pieces missing. You should be able to get to all the other pieces based on the notes we've taken. So if something has 27 protons, remember, protons tells us who it is. It's the fingerprint of the atom, I like to say. So it tells us who it is. We're going to find element 27, and we're going to say that it's cobalt, so its symbol is CO. It's going to have 27 for its protons, or atomic number, and then I got to add protons plus neutrons, so 59 for its mass number. And then I got to check to see, is this an atom, or is this an ion of cobalt? In order for it to be an atom, protons and electrons must be equal, and they're not. So I have more protons by 3, so it's 3 plus for the charge. Mostly you'll see people do it different ways, 3 plus or plus 3. You'll see me flip-flopping because I learned it the other way, plus 3. Officially, it should be the number then the symbol, but I'll take either one. Next, we have 8035Br. We know that it has 35 protons and 35 electrons. Why both are the same? Because there's no charge here. And to get my 80, I'm going to turn this into a subtraction problem. Okay, so that is going to get us what? Do that math on your calculator. You should come up with 45. Okay, so now next one, 25 protons. Remember, the proton tells us who it is, so we're going to look for element 25. We know that's manganese. Okay, so 25 is going to go here. That's a horrible M. That's a capital M as in Mary. And then I got to figure out my mass number. I'm going to take protons plus neutrons, so in this case 55. And then I got to check to see, is it an atom of manganese or an ion of manganese? Well, they're not equal, so I have to do some subtraction here. And I'm going to see that I have a 7 plus charge when I do protons minus electrons, so 7 plus charge. Here again, I can turn this into a subtraction problem, so I get 16. I know I already have 16 protons because the bottom number is the protons or atomic number. I also know that it's a 2 minus, so I have 2. 2 minus means I have 2 extra, so I have 18 electrons. And then I know that I must have neutrons of 16, because remember when I turn the subtraction problem in here, it gives me the neutrons. How did I get the 18 again? Remember, I have 16 protons, and I know I have a 2 minus, so I gain 2 electrons. 2 minus means I'm more negative. More electrons means I'm more negative. Next, we have 9. That's going to be fluorine. Remember, this tells us who it is, the atomic number. So find element 9. And you're going to fill in this as 10. Pardon me, that's not correct. You're going to fill this atomic number in as 9. And then you're going to say that you have 9 plus 11, which is 20 for the mass number. And you are going to then figure out if it has a charge or not. I have 9 protons and 9 protons and 10 electrons, so I have a 1 minus charge because I have more electrons than I do protons. Next is carbon. So 6 tells us it's the protons. And then I know that the electrons are 0 because there's no charge on this. There's no plus or minus right here. And I can turn this into a subtraction problem to figure out that I have 8 neutrons. Remember, neutrons, I can take my nuclear symbol to figure out my neutrons.